need to show that this given surface integral is equal to 4 by 3 into pi into a plus b plus c, where s is the surface of the sphere x square plus y square plus z square equal to 1. That is the unit sphere. So again we have to apply the Gauss's divergence theorem to show this result. So this is the given integral, and let's consider V to be the region enclosed by the surface S. Then, by Gauss's divergence theorem, this given surface integral is equal to the volume integral of divergence of this vector. And the divergence of a vector can be written as del dot of this vector. That is equal to the volume integral of, what is del? It is curly by curly xi vector plus curly by curly yj vector plus curly by curly zk vector and its dot product with this vector, right? Okay, so this is further equal to the volume integral of curly by curly x of ax plus curly by curly y of by plus curly by curly z of cz dv. So this is volume integral of, curly by curly x of ax, that is a, then it is b, then it is c dv. So this volume integral is the triple integral of a plus b plus c, and dv is written as dx dy dz, where the surface given to us is the unit sphere. Now writing the limits for x from this surface. So x is equal to plus minus square root of 1 minus y square minus z square. So the lower limit is negative of square root of 1 minus y square minus z square, and the upper limit is square root of 1 minus y square minus z square. And now writing the limits for y, for yz plane, we take x equal to 0. So from this surface, we get the limits of y to be as plus minus square root of 1 minus z square. So the lower limit is minus of square root of 1 minus z square, and the upper limit is square root of 1 minus z square. And for the coordinates of z, we take x equal to 0 and y equal to 0, and from this surface, we write the limits of z as plus minus 1. So the lower limit is negative 1 and the upper limit is 1. Taking this constant outside of the integrals, solving the innermost integral first. So integration of 1 with respect to x is x. With limits, putting the upper limit minus putting the lower limit, we get twice of square root of 1 minus y square minus z square, right? Writing this 2 outside. And now we have to integrate this with respect to y. For this, I'm writing 1 minus y square minus z square as 1 minus z square minus y square. That doesn't matter. And now we are going to apply the formula for this integration. Because this is your even function, and whenever we are having the even function and the limits are also same with opposite sign, this integral becomes twice the integral of square root of 1 minus z square minus y square, but the limits are from now 0 to 1 minus z square under the root. Taking this 2 outside, and we get 4 times a plus b plus c. And to solve this integration, we are going to apply the formula for this. That is y divided by 2 square root of 1 minus z square minus y square plus square root of 1 minus z square whole square divided by 2 sine inverse y divided by square root of 1 minus z square, with the limits from 0 to square root of 1 minus z square dz. So square root of 1 minus z square whole square becomes 1 minus z square When we put the upper limit, we get this term to be equal to 0, and this term becomes sine inverse 1, that is pi by 2. So this is 4 times a plus b plus c, integral of minus 1 to 1. When putting the upper limit, we get first term to be as 0 plus 1 minus z square by 2 into sine inverse 1, that is pi by 2, minus putting y equal to 0 over here, we get 0, and also if you put y equal to 0 over here, you get 0. Sine inverse 0 is 0. So this is 0 dz. So this is 4 times a plus b plus c, integral of pi into 1 minus z square divided by 4 dz. Taking this pi by 4 outside, and this 4 gets cancelled out. Again, we are having the even function over here. And for the even functions with same limits with opposite sign, this integral becomes twice the integral of 1 minus z square dz, but the limits are from 0 to 1. So this is equal to 2 pi a plus b plus c, integral of 1 minus z square dz, and the limits are from 0 to 1. So this is 2 pi into a plus b plus c, integrating 1 with respect to z, we get z, minus integrating z square with respect to z, we get z cubed divided by 3, and the limits from 0 to 1. So this is 2 pi into a plus b plus c. Putting the upper limit, we get 1 minus 1 divided by 3, minus putting the lower limit, we get 0. So this is equal to 2 pi into a plus b plus c, and this is 2 divided by 3. So that is equal to 4 pi by 3 into a plus b plus c. Hence we have shown this result. So hence we have shown that this surface integral is equal to 4 pi by 3 into a plus b plus c. Alright, thank you.